Hello, everyone. I'm Ted Grantham. I'm a cooperative extension specialist and adjunct professor at UC Berkeley. On behalf of the Public Policy Institute of California's Water Policy Center, welcome, and thank you so much for joining us today. PPIC has released a new report entitled Making the Most of Water for the Environment. This new report describes a functional flows approach to environmental water management. This approach seeks to restore seasonal components of a river's flow to sustain the biological, chemical, and physical processes necessary for ecosystem health. Now, we had over 600 people register to attend this virtual event, so thank you so much. I'm not sure if this reflects a particular interest in the topic or is a sign of desperation and folks are just trying to get their minds off the current state of the world, but in any case, thank you so much for coming. I want to acknowledge my co-authors on the report, Jeff Mount, Sarah Yarnell, and Eric Stein, as well as the contributions of the California Environmental Flows Work Group, which I'll talk about a little bit later. I also want to recognize and thank the St. Bechtel Jr. Foundation and the funders of the PPIC CalTrout Ecosystem Fellowship. I was the first PPIC CalTrout Ecosystem Fellow that made this work possible. The report, as well as the slides from today's presentation, are now available online at ppic.org. There's also a short policy brief if our full report is a bit too much to wade through. This event will also be recorded and posted on the website in the near future. Now, we have a 1-hour program today. It's going to start with a short presentation by me, followed by a panel discussion and a Q&A session. If you have a question for me or the panel, please send an email to the address shown on the screen. Make sure to include your name and organization along with your question, and we'll get to as many of them as we can, okay? Now I'm just going to pull up my presentation. All right. We're going to start with a short presentation that will provide an overview of our new report. The primary goal of the report is to introduce a new approach for managing environmental water in California. I'll describe some of the challenges with our current approach and how the concept of functional flows can be used to improve environmental water management in the state. I'll explain how functional flows could be put into practice in different river contexts and recommend a few governance changes that could be helpful for implementing the approach. Simply put, current approaches to managing environmental water aren't working. They aren't working particularly well for ecosystems, and they aren't working particularly well for people. We know freshwater ecosystems are suffering. For example, of the state's 125 native fish species, 7 are already extinct and about 100 are in decline, including half of California's salmon and steelhead species. The potential for additional species listings under the ESA also represents a major source of uncertainty for water users, making long-term planning more difficult. And despite significant investments in environmental protections, trends in ecosystem degradation continue. One of the fundamental problems is that environmental flow requirements tend to take the form of minimum in-stream flow standards. These are minimum flow levels that must be satisfied on a monthly or seasonal basis. Now, this flatline approach tends to mute the natural variation in flows that is really critical to supporting ecosystem health and meeting the needs of freshwater species. Second, by and large, environmental water management in the state is focused on the needs of particular species, those listed under the Endangered Species Act. This single species approach tends to overlook the needs of other species, as well as the physical and biological processes that are really important for sustaining long-term ecosystem health. Finally, there are a diverse set of laws and regulations that govern environmental water, but these are poorly coordinated and inconsistently applied. There is no overarching regulatory framework for managing environmental water, and this piecemeal approach has resulted in insufficient environmental flow protections in many of our rivers, including many rivers with no protections at all. As an alternative to the current approach to environmental water management, we propose a functional flows approach. The term functional flows was first used by Marissa Escobar Arias to describe the flows that support geomorphic processes important to salmon. The concept has since been expanded by Sarah Yarnell and others to consider the biological, chemical, and additional physical functions of flow that occur throughout the year. In California, these components include the fall pulse flow that triggers fish migration, wet season peak flows and base flows that support important physical functions, the spring recession flow, which cues reproduction for a whole host of native plants and animals, and dry season base flow, which sustains aquatic habitat throughout our long dry summers. Now, by preserving these functions that are essential to ecosystem health, we believe functional flows represents a more efficient and effective approach to environmental water management. It's important to note that in order to support the function that flows provide, physical habitat conditions must also be considered. This includes the river channel, banks, and floodplains that interact with flowing water to create and sustain habitat for aquatic species. For example, high flows confined between levees, such as shown on the left, won't support the beneficial floodplain functions provided by high flows that you see in the landscape on the right. The functional flows approach emphasizes the importance of suitable physical habitat and recognizes that to fully realize the benefits of environmental water, physical habitat improvements will often be needed. So how can we take this concept of functional flows and apply it to manage environmental water in a different way? One way in which the concept can be used is in assessing environmental flow needs. The first step in the process is articulating what we're trying to achieve with environmental water. Now, traditionally, the goal would be to meet the habitat needs of particular species, such as threatened salmon, like I mentioned earlier. But under a functional flows approach, our goal would be to preserve those flow components that support essential ecosystem functions, not only to support salmon, but also the many other species that depend on rivers and streams. Next, technical work would be conducted to quantify the specific flow targets that are needed to support ecosystem functions. Basically, we need to figure out the flow thresholds that must be surpassed or met in order to support each of the desired functions. Once those targets are established, strategies for meeting ecosystem needs, along with other management objectives, including water supply and flood control and so forth, would be developed by assessing trade-offs and specifically by exploring how physical habitat improvements could help to limit conflict among these various management objectives. These might include actions such as levee setbacks, physical recontouring of the landscape to increase water and land interactions, and in-channel habitat improvements. The end result would be a set of environmental flow standards or targets, as well as a potential suite of restoration actions that can be implemented in a river or watershed. The steps that I've outlined here are a highly abridged version of a much more complex and detailed process that's been developed under a project known as the California Environmental Flows Framework. This work is independent of PPIC and is being led by a technical team of scientists from UC Davis, including Sam Sandoval-Solis, Sarah Yarnell, and Rob Lusardi, Belize Lane at Utah State, Julie Zimmerman and Jeanette Howard at the Nature Conservancy, and Eric Stein with the Southern California Coastal Water Research Project. The efforts also benefited from the input of staff from several state agencies, especially the state. The overall goal of this framework, this California Environmental Flows Framework, is to help managers improve the pace and technical rigor in setting environmental flow standards statewide. It establishes a standardized process for determining the specific flow values needed to improve ecosystem health by preserving functional flows across the state's diverse geographic and management settings. The framework and document itself and supporting tools aren't quite ready to be released yet. We expect them to be out later this year, but updates can be found on some of the websites that we reference in our report. Now, once environmental flow targets are established for a river, either through the framework or other environmental flow assessment approaches, how do we actually put functional flows into practice to meet those targets? In large rivers such as the Sacramento, with flows largely regulated by dams, this would primarily be accomplished through changes in reservoir operations. Specifically, the timing and magnitude of water releases would be modified to meet functional flow needs. These water releases would augment existing releases or spill events potentially to restore targeted ecosystem functions. Implementing functional flows in these settings would also likely require physical habitat improvements, especially the restoration of floodplains, but potentially also improvements to in-channel habitat. This is what the flow regime of a dammed river might look like. In this figure, we see the existing flow regime, basically under current management practices, which is shown in green, which contrasts with the natural flow regime that's shown in light brown. As we can see, a substantial fraction of the river's natural flow has been removed from the river. This is water that's been diverted and stored for flood control, water supply benefits, and other uses. Under a functional flows approach, environmental water would be strategically allocated to restore the specific functional flow components that are shown in blue. It's important to note that the functional flow regime still deviates significantly from the natural flow regime and doesn't require a constant proportion of natural flow throughout the year. So it's likely that we can still satisfy critical water management objectives while also restoring ecologically important aspects of the flow regime. Putting functional flows into practice in undammed rivers would require a different approach. The primary means of managing functional flows would be the regulation of water diversions. Changes in the timing, volume, and location of diversions may be required to ensure that functional flow targets are met. In some cases, groundwater withdrawals would also need to be modified or curtailed to make sure that enough water was being maintained in stream. Now, the management of functional flows in urban rivers faces some unique challenges owing to a long history of physical habitat modifications. But we still believe the functional flows approach is still applicable in such systems. In addition to potential changes in dam operations and water diversions, managing for functional flows in urban rivers may also require changes in the volume and location of discharges from wastewater facilities. Watershed restoration efforts to limit stormwater runoff may also be needed in these urbanized systems. Now, to our knowledge, the functional flows approach we are advancing has not been implemented in any of the state's rivers, but there are places where elements of the approach can be found. One example is Putah Creek, which flows through the city of Davis and into the Sacramento River through the Yolo bypass shown in this map here. Flows in Putah Creek are regulated by releases from Berryessa Reservoir and the Putah Creek Diversion Dam just downstream. The creek supports a really diverse assemblage of fish species. Just below the dam, native coldwater fish are found and dominate the fish assemblages there. But as water is warmed downstream, we find many of the native fishes that are native to the Sacramento Basin. As we move even further downstream, introduced fish become more dominant owing to habitat degradation. During a major drought in the early 90s, native fish populations in the creek plummeted. And this led to a legal settlement, a legal battle, and ultimately a settlement over water operations, and specifically the operation of the Monticello Dam and the Putah Creek Diversion Dam. And this settlement agreement developed new environmental flow requirements for Putah Creek. These flow requirements were developed from recommendations by fish biologist Peter Moyle, focused on the restoration of specific elements of the flow regime that were important to the needs of native fishes. These recommendations included higher spring flows to support the spawning and rearing of native resident species, enhanced summer base flows to prevent creek drying, and winter pulse flows to improve physical habitat and suppress non-native species. Overall, the total increase in water allocated to the environment was about 20% over pre-settlement conditions, but the changes in seasonal flow patterns has resulted in a really remarkable recovery of native fish populations in this system. And this is described in a study led by Joe Kiernan a few years ago. Now, while every system or stream will have unique characteristics and can't be expected to respond in the same way as Putah Creek, I still think it's a really powerful example of how relatively small changes in environmental water management to restore functional flows can result in really dramatic improvements in the ecosystem with, again, relatively small impacts on water users. Moving away from technical implementation aspects, I want to highlight a couple of dimensions of our report that address the legal and governance challenges of environmental water management. Building on previous recommendations by PPIC, we believe that implementation of functional flows would greatly benefit from ecosystem water budgets. Following the model developed in Australia, ecosystem water budgets are fixed volumes of water that are allocated to the environment. And ideally, these would function as a priority water right, and like any water right, could be flexibly managed, traded, or sold. The amount of water available to the environment would vary by water year type and would be managed by some sort of independent ecosystem water trustee. The figure on the right is actually from the Trinity River, another system in which elements of this functional flows and water budget approach are being put into practice. We believe a water budget would give maximum flexibility to the trustee, to the environmental water manager, and determining how water should best be used, and would also make the trustee accountable for decisions to ensure that environmental water is really put to the best use and the most effective use. Furthermore, we believe that water budgets would also provide increased certainty to water users in planning and decision making by knowing exactly how much water the environment will be allocated. If you're interested in learning more about ecosystem water budgets, I encourage you to take a look at previous PPIC reports led by Jeff Mount on the topic. Finally, I'd like to share that, to our knowledge, there are no legal barriers to implementing functional flows. Based on a thorough legal review led by Brian Gray, we determined that existing water management planning and regulatory proceedings could readily be adapted to incorporate functional flows. These include water quality and water rights proceedings under the authorities granted to the State Water Board and other public trust doctrine and Porter Cologne Acts. The state and federal Endangered Species Acts also have provisions for more holistic approaches to ecosystem management. The Federal Energy Regulatory Commission, or FERC, licensing process also includes really strong provisions for environmental flows, and I think provides a helpful model, though one that is perhaps a bit too slow. And finally, we believe there are clear opportunities for incorporating functional flows and a functional flows approach in the implementation of the Sustainable Groundwater Management Act. Our hope is that through the adoption of the California Environmental Flows Framework and similar efforts, we can begin to integrate and harmonize these regulations into a consistent statewide approach to environmental water management. Nowhere in my presentation or in the report do we say this is going to be easy. Managing for environmental water will continue to be a challenging and controversial issue, but we can do better, and we think that the functional flows approach described in this report offers a substantial improvement over the status quo. By focusing on the components of flow that support ecosystem health, we can increase efficiencies, basically getting more pop per drop, as we say, for environmental water. By better integrating land and water management, we can also incentivize multi-benefit projects that work for people and the environment, such as the creative floodplain projects that we're starting to see in the Sacramento Valley. Finally, we think this approach is ultimately better for people by providing greater assurances that environmental water is being used effectively to improve ecosystem health. Thank you so much for your attention. That's all I have today. I know it's a bit of a whirlwind, but we're going to move quickly on to the panel discussion. If you have any questions, feel free to send them to PPIC now, or you can reach out to me directly. And at this point, I am pleased to introduce my esteemed colleague, Dr. Jeff Mount, Senior Fellow with PPIC and co-author of our report, who will be facilitating the panel discussion. Thank you.
Thanks, Ted. I really appreciate it. And of course, that was a great talk. And for those of you who follow this, you know full well this is a complicated and controversial issue. So I want to encourage folks to go ahead and download the report from the PPIC website. There's also a whole bunch of reports related to this that would be really, really useful. Today I have the pleasure of introducing some panelists who work in the trenches on this stuff, and it's going to be it's a chance to listen to somebody else talk about sort of real life experiences trying to deal with managing environmental water and how it relates to the work that we just did here. And I'm going to go ahead and introduce them in the order that I'm going to ask them questions. But first, I want to remind you, I am not going to spend a lot of time in their bios. Their bios are all on our website. I want to encourage all of you to go there. The first panelist we have is Bronwen Stanford, and Bronwen is probably known to many of you who work in this field. She's currently with the Department of Fish and Wildlife, California Department of Fish and Wildlife, and is a leading member of the in-stream flow program there. She's got broad experience, and we share a pedigree from UC Santa Cruz. So there you go Slugs. Our second panelist is Julie Zimmerman. She's the lead scientist for the Nature Conservancy's water program here in California. Julie has an extraordinary background and worked in a variety of places on this very issue, and is really one of the leading minds in trying to do this work, and has collaborated with Ted on some of this in the past. And by the way, she's a Gaucho. Go Gauchos. So see, this is the connection. This is the DNA that links us all, our education. The last panelist we have here is somebody I've known for years, literally decades, and his name is Mike Belchik, and he's the Senior Water Policy Analyst for the Yurok Tribe. Those who've worked in the North Coast know Mike very well. He's done extraordinary work in the Klamath and Trinity Basin, and right now he's really sort of the tip of the spear, is the best way to describe it, on the Klamath Dam removal efforts that are going on right now. That'll be actually part of the questions that I'm going to ask him. But let's go ahead and start with Bronwen. And Bronwen, and again, thanks for showing up today and being willing to answer our questions. I want to give you a chance to sort of reflect on this. In your role, you are at Fish and Wildlife, you are grappling daily with this, trying to set in-stream flow criteria. And if I understand Ted correctly, and he's reported this, most rivers in California actually don't have real in-stream flow criteria, particularly the unregulated, so many of the unregulated rivers on the Central Coast and North Coast in particular. So one of our questions for you right off the bat is whether this notion of functional flows is even useful to the kind of work you're having to do as you are grappling with this massive amount of uncertainty in these rivers. So I thought I'd give you a chance to tell us whether we're just making stuff up or whether it's useful or not.
Thanks so much, Ted. And yeah, thanks to everyone who's listening today. That's exactly right. So in the in-stream flow program of CDFW, our mandate is to help the state, or is to come up with flows that we believe will be protective of fish and wildlife and their habitats. And we work all over the state. A lot of the rivers that we work on are the smaller unregulated rivers that Jeff mentioned. And it is certainly a challenge. So just to maybe, before talking more about functional flows briefly, so what we do, we often will do a lot of intensive fieldwork, sort of site-specific studies that tend to be focused on really understanding the needs of a particular species or life stage. So we'll answer questions like how much water is needed for a returning coho to pass upstream in this river, and then once it gets there and spawns, what sorts of flows would produce the depths and velocities that are going to give it habitat where it can forage and grow and hopefully be a healthy and returning fish. And we're sort of using a lot of methods that have been around for decades in many cases. As Ted alluded to, there are certainly some limitations with these methods. One of the limitations is that they just don't, it's hard to capture the full range of conditions that a stream might really need over time. So maybe we'll focus on rearing habitat for coho, but won't be able to get to thinking more broadly about some of these peak flows or pulse flows and some of the other functions that we might be missing. And it sort of tends to be more of a snapshot view. And these approaches are also often very time consuming. So we are really excited about the functional flows approach because it has the potential to help and answer a lot of these questions that we're still left with. One of the really powerful things about it is that it embeds this idea about what some of the key pieces of the natural hydrology are. So in a lot of the streams in the state, especially the smaller unregulated streams, we are often really data poor in terms of understanding what sort of natural conditions would be for that site, what it's likely that the species that are there adapted to, and what might help to push them from barely surviving into a thriving state, or as near to that as we can get. So that the information that it provides about what some of those important flows would have looked like under a more natural flow regime is really important. The focus on functions is really exciting. So we've understood for the last several decades that rivers are meant to be dynamic and variable and change over time. Managing for a single flow or a limited set of flows is not going to is not going to maintain the full health that we would hope to see for that river. So focusing on these functions, the variation over time, the high flows and the low flows, and capturing the full hydrograph is extremely powerful and is something that a lot of the traditional methods have struggled to do. And then finally, part of the package that Ted and others have been working on is going to be a set of metrics that go along with these key functions. So it's going to be giving a sense for some actual numbers that we can tie to these functions that we might conceptually know are important, which gives a really powerful starting place for water managers who, or our folks out in some of our different regional offices who often don't have a lot of information about how to set expectations for that stream. So no, I'm hopeful it will be really helpful to help us think more broadly about the needs of the stream over time and the range of flows that would be most supportive of species.
Great. Thank you, Bronwen. Let's you said something that's a good handoff to Julie. So let's kick this problem to her. So Julie, I mean, you've been working for 15 years on this problem in a variety of places all over. And you yourself have run into this problem that Bronwen kind of alluded to, that we tend to focus real narrowly on a single life history stage of a single species and the single flow. And I think of FERC relicensing as a great example of that and the use of the models that they have. So Julie, I just sort of, I want you to give us a sort of since you're actively working on this with the Nature Conservancy right now, how those approaches have perhaps handicapped us and how this might be a better approach, particularly if you want to think about it on unregulated rivers where we really are truly fighting a lot about the water. So Julie.
Right. I mean, I've been working on this question mostly in California, but also on the East Coast. And I have the, I guess, benefit of looking at it from a lot of different kind of perspectives. So I've done it as an academic, and I worked for an agency, the Fish and Wildlife Service, on CVPIA, and then also now with the Nature Conservancy. And I think that for me, this is really exciting because everywhere that I've worked, the scale of the problem and the complexity of the problem is really overwhelming. I mean, there's nowhere that I've worked where we've been able to come up with a really comprehensive set of flow recommendations that we think will be ecologically protective. We do usually apply these methods that focus on single life stages. A lot of the hydraulic habitat modeling focus just on spawning of salmon or maybe rearing of juvenile salmon. And then even if you think about more of the flow ecology response curves, those approaches such as ecological limits of hydrologic alteration, you're focusing on one ecological metric, maybe a couple or a few if you have the data, and then one or a couple flow metrics. And usually it's really governed by data availability. So there's a lack of gauges in the state, and we have to kind of rely on where we have stream gauge data and where we collect macroinvertebrate samples, or we have fish data, and it's limited. It's limited to those streams where we have spent time. We have, usually some alteration, which kind of spurs the issue and forces us to start looking at these flow problems. And it really kind of simplifies what is a very complex problem. So I've been working on the California Environmental Flows Framework technical group with Ted and others. And one thing I'm super excited about with this is that we've been able to come up with these flow metrics that describe functional flows for every stream reach in the state. So we've really kind of addressed that spatial problem where right now we only have flow recommendations for, I haven't done the math, but it's probably less than 1% of stream miles in the state of California where we have some kind of target even to shoot for. And now you can go to this web tool that we've developed and click on any stream reach in California and pull up the functional flow metrics and those quantitative targets for what the flows should be and what the duration of those flows should be and when they should start and when they should end. And all these questions that we've really been trying to develop in other places. And I don't know of anywhere where we've been able to do that. And I think with implementation in those regulatory processes, I mean, FERC is a good example. They tend to focus on these quantitative methods that give you these trade-off curves. So they want to say, if we're going to change flows, what will the change in ecological response be? I think we're still going to want that because that helps us to look at balancing for different uses of water. It helps us look at, what kind of flows are protective for ecology versus, what happens if you change flows to some degree. But we're never going to be able to do that everywhere at the scale where it's necessary. So I think this framework helps us to have an initial set of flow targets that we can get for any stream. And then if there are specific questions about trade-offs or competing objectives for water management, we can put that time into developing those flow ecology response curves in those places.
That's great. And again, you're in the trenches. I'm going to come back to you in a little bit with a follow-up question on that, because I want to jump to Mike now and talk to Mike. So we think of the sort of functional flows we talk about physical habitat as being essential. And I do want to swing back to the panelists and talk a little more about that role of achieving functional flows. But Mike's in the middle of the biggest habitat restoration, technically the biggest habitat restoration probably in the history of California. And at the same time, he's up on the Klamath River. And those of you who work in the trenches down here in California in the Central Valley, it sucks all the light and energy and matter and everything else. We tend not to pay as much attention to the Klamath, but they're really grappling with some very important issues. And it is probably California's stronghold for salmon for the distant future. So Mike, what I want to do is you unlike Bronwen and Julie, you've not been involved in this sort of day-to-day dealings with the functional flows and the development of them. But I wonder how this relates to your work over the last 20 plus years in the basin. Everything from managing fish disease to spawning and rearing habitat and barriers and all the rest of that. So I just wanted to give you a chance to weigh in on that, Mike, and give us your input.
Okay. So I think to start with, I work for an Indian tribe called the Yurok Tribe. It has about over 6,000 tribal members. That colors what we do. I've been working there for about 25 years now. And simply put, we were given a job early on, and that was to restore all the fisheries in the Klamath Basin. As part of that, we view flows and functional flows as a foundational element. In other words, you can do all kinds of stuff for fish restoration, put in habitat projects and things like that. You're not going to really achieve any type of restoration unless you have the right flows. I think the Trinity River in around the year 2000 made a really good attempt at this exact concept. The Trinity flow regime was based on functions, geomorphic functions, ecological functions, but at the same time was less overall volumes than the natural flow. When we look at like what's happening on the Klamath and the Trinity, a real premise of where we come from is that it takes more than just looking at the fish or even just the water to really achieve ecosystem restoration. So for example, the Yurok and our neighbors upriver, the Yurok Tribe, are really involved in landscape level restoration that includes burning and cultural practices. So there's a real crossover between this cultural knowledge, the traditional environmental knowledge, simply put, things that the tribes have always known that are now being backed up by Western science. And so when we look at the Klamath River, we spend quite a bit of time arguing over flows. And the regulation that seems to be able to keep water in the river is the Endangered Species Act. So we do a lot of arguing over coho habitat curves and what about fish disease, what happens with that and things like that. But in reality, that's not what it's all about. The Klamath River has 3 different runs of salmon. It has coho, 3 different runs of steelhead. There's 2 runs of lamprey. There's green sturgeon, candlefish. You get the picture here that there's something happening every day of the year. And by providing flows that take care of one species or life stage, it's not really going to do the job in setting that. And so that is one of the reasons we got involved in the dam removal. So there's 4 dams on the Klamath. The Klamath is the 2nd biggest salmon river in California. and reconnecting the basin. The dams don't really affect flow except on a weekly or seasonal basis. The flow comes from a natural lake up in Oregon called Upper Klamath Lake. But when you're really putting the whole picture together, sediment management turns out to be extremely important. Lamprey, for example, need fine sediment in order to thrive. The lack of sediment has caused armoring of the bed, and fish disease therefore has spiraled out of control. The sea Shasta is just like it got 90% of the out-migrating class a couple of years ago during a drought. So this idea of the functional flows, I think it's something that really is on the right track here. And it's really important to understand things like, I'll take the Trinity, for example. They had the idea right that we need to move gravel every year in order for a dynamic river system to happen, that we need to unentrench the riparian area that's causing these fast flows, fast water velocities. But if you do it at the wrong time of year, like in the springtime, like they're doing on the Trinity, well, it turns out you have big time impacts on the food chain, on the food web, the microinvertebrates. And so people are starting to re-examine. There was a flow regime put forward. Trinity River fish aren't recovering as fast as we thought. So this science is new. There is an adaptive management framework, but there's a big learning curve. Essentially, what we're doing here is we're taking a river that was unpredictable and functioned on its own, and we're trying to see, well, just how much water can we take out of this river and not lose the essence of the river. And the whole premise of the question from the tribe's viewpoint is problematic to begin with. What the river needs is all of its water. That's what makes it function. And so we look at it as a subtractive process, not an additive process. I would say that when we look at the water flow in the Klamath, things like dam removal, sediment management, and most importantly, water quality are all the elements that we need to put this river back together. And that's what we're working on.
Great, thanks, Mike. So, and again, we could do this whole thing on just the Klamath, and maybe we should at some point in the future, because it's such an interesting place to work. But I want to swing back real quickly to Bronwen. I'm a classic academic who throws out these ideas, and you all take care of this for me, won't you? And Bronwen, it's got to be darn difficult to do this. And I'm sure we're going to get some online questions here in a bit. What do you see as like the major hurdles to actually applying this as the functional flows and the work that you're currently doing?
Yeah, I think that's a good question. So I think the biggest challenges are really around the fact that it is new and it's different. As everyone so far speaking has alluded to, managing environmental flows and stream flows is extremely contentious. So there's a really high premium on being very transparent, using established methods, making sure that the things you're doing are defensible, that you're communicating clearly. And a lot of these places, people are used to the way that things have been done for decades and the methods they're used to seeing. They're used to doing maybe more intensive site-specific studies rather than relying on the metrics that Julie described so well that are kind of now available for all these reaches in the state. So I think there's a big task, and it'll be interesting to see how we can progress in the next few years as we work through sort of having all of the conversations, doing the education about the strengths and limitations of these approaches, thinking about how best to translate some of these functions into either translate them into the existing sort of regulatory frameworks that we have, or thinking about ways to maybe update some of those frameworks so that they can be more accepting of these flows that maybe are variable over time. I think certainly there's understanding throughout the state that like we need this wide range of flows, and I think just helping people understand how to make those happen and how to feel comfortable that they will be defensible and that they will be useful communication tools, I think is one of the biggest challenges that we're looking at.
Great, and that's a good handoff to Julie at this point. Julie, and this is not one of the questions I prepared you for, but it says it enough. And I'm sorry to put you on the spot, but implementation is still a real challenge. If you could choose one thing, and of course that's ridiculous, there's many things, but if you could choose one thing that would help you guys actually implement this, what would it be? Is it change in law, change in policy, money? What would you do? What one thing would you need, which would be allow you to actually begin to implement this?
Oh, that's a tough question. Right. I mean, I feel like the path that we've been working on with this technical group, which I've really liked, is trying to make it so that hopefully changes in policy will reflect what we've created, right? So that right now there's a bunch of methods that you can apply to any given stream. And usually you have to do a big site-specific study to be able to come up with a target to then justify any changes in, how you use your water rights or change of use or anything like that. And I'm hoping that the tools that we're creating as part of the California Environmental Flows Framework will then kind of work towards satisfying a lot of those demands. I mean, I think that the short answer is we need all those things, right? We need changes in laws, we need changes in policy, we need money, but we've spent, with the Nature Conservancy, we've spent a lot of time and money doing site-specific studies to support some of our implementation projects. And I'm hoping that what we're producing now help us to kind of shift those resources to doing projects on the ground. And we're already doing it. I mean, we own a water right in Mill Creek in the Lassen foothills, where in the past, when we first bought it, we entered into an agreement with Los Molinos Mutual Water District so that they would release our water in the spring when there was, some concern about salmon, and then they would use the Nature Conservancy's water in the summer. But what we found is that the flows in Mill Creek are usually drying up in the summer, so we don't have any flow. So using this approach and some of the work that Bronwen's group has been doing, we looked at all those functional flow components and said, well, our water is just this really small proportion of spring flows, but it can make a significant contribution to the summer dry season full of pulse. So we should switch how we're using it and actually leave it in the stream at all times. And we think it would be more useful for supporting native species if we do it that way. So we actually ended our agreement with Los Molinos, and now we're working on leaving it in stream all year, and we're hoping we have perennial flows back in Mill Creek. So it's already changing how we're implementing on the ground, which I think is exciting.
Great. By the way, you just sort of led into something we'll get into probably later, and of course that's an ecosystem water budget. In this case, it's your water right and the way you use your water right. So let me transition to Mike before we go to the Q&A, online Q&A. And Mike, this is to be short because my handlers make sure we want to get to the Q&A. I want you to tell me a little bit, to expand a little bit on this notion that we are obsessive about flow, and you started to allude to the fact that it is so much more than flow. And this is a point we try to make in that report, that functional, just water alone is not enough. You're going to have to do more. So I wanted to give you a chance to expand for a couple of minutes on that, because that seems to be so important in the Klamath Basin, and including the tributaries that, like the Scott and the Shasta. So Mike, if you could just expand for a little bit, and then I say we're going to jump to Q&A in a little bit.
Well, I think it just, the mission that we had, which is to restore all the runs of fish, doesn't really lend itself to like looking at the habitat needs of one species and saying what the flow needs to be there. And also the Yurok Tribe's located down at the mouth of the Klamath River, far away from things that influence the flow of tributaries like the Shasta and Scott and the main stem Klamath, 190 miles upriver where Iron Gate Dam is. When we started looking at like what it would take to really restore the river, one reason why I like working for the tribe is that the tribe's never been afraid to think big and to think about what it takes to really restore this river. And this is what our advice was to them early on, was that it's going to be more than just flow. And we're finding out now, as we were, and our neighbors, the Yurok Tribe upriver, were the first ones to start talking about removing the dams back in 2002. That was 18 years ago. We looking at the information and saying, hey, this would be a good thing for the river. But the more we uncovered about the effects of the dam, about effects to temperature, sediment interruption, nutrient dynamics, connection, access to cold water in the face of climate change, we started to believe, we started to understand that this is a fish restoration project. I mean, our ambition here is to bring back the spring run that's extinct from that part of the river. Spring run Chinook salmon I'm talking about. So all along, the tribe in its traditional environmental knowledge has always known that it's really landscape that affects these fish. The nutrient flux, what is the fire history, what is the nutrient influx, what about the sediment budget and things like that. That's what it's really going to take. And you take a look at how the landscape used to function, and you try to restore all of those things. But like I said, flow is still a foundational element of the fish restoration. Yeah. That said, you take care of all these things, you still need a good foundational flow, or you will not achieve your restoration.
It was Mary Power from Berkeley who years ago said flow is the master variable. We can't ignore that. I do want to remind everybody who's online to go ahead and send an email question to us, which is ppiceventquestions@gmail.com. There you are. And what I would like to do is transition into the audience Q&A and bring everybody back, including Ted. Ted, you can start your video, and there you are. And I'm going to, the way I'd like to set these questions up is I'm going to direct them to one person, but I want any of you to chime in and answer it as you see fit. And I will tell you right now, we have a lot of questions, so far more than I think we'll be able to get through it here. But actually, it's great. Our first question comes from somebody we cited earlier, Dr. Marissa Escobar, who's the head of the U.S. Water Program for the Stockholm Environment Institute, and really wrote some of the early papers on this concept of functional flow and deserves a lot of credit. And she raises an interesting problem here. So, at SEI, she's worked on this issue all over the world, including areas where your seasonality is much less than we have here in California, and doesn't drive things as much. But her point was that you really focused on seasonal flow events, but the fact is the biology lives day to day in the river. And how does functional flows work on a daily basis? Again, because the biology is embedded in the daily variation, not these big changes. And so, Ted, I'm going to throw it your way and invite others to chime in afterwards if you want to answer that.
Sure. I mean, first I would say that among the functional flow components that we identify, many of them are these sort of seasonal events that do sort of geomorphic work or physical work, like the wet season peak flows and the spring recession flow. But we also include things like the winter season base flow and the dry season base flow, which are sort of sustained low flows that also support a lot of important ecosystem functions. So I think if we really we do address sort of all aspects of the hydrograph. Now, I think depending on the context in which this type of approach would be implemented, it probably would be important to complement those seasonal flow components with potentially other flow targets. And I'm thinking specifically of hydropower dams, where we see high, diurnal or sub-daily fluctuations in flow, where it probably would be necessary to set additional flow targets to mitigate those impacts in some way, because those can obviously have a major impact on aquatic ecosystem health and function. So I would say that so generally speaking, I think the components that we've identified do really address the flow needs throughout the year, including periods in which flows are quite sort of stable and not doing much from sort of a physical perspective. But there will be unique water management contexts in which they would need to be, flow criteria or targets would need to be developed to address specific pressures on the system.
Cool. Bronwen, Julie, or Mike, if you don't want to chime in, that's perfectly fine. I can go on to the next question, unless you want to say something. Nope.
Sure. I mean, I think Ted had a really good point that there's a difference between setting these seasonal flow targets and actually implementing them. And the implementation is, I think, where we have to do a lot of the additional work. But that's where, we can really focus on what the time step of what actually gets implemented when you look at an ecological flow regime. Should it be the entire dry season base flow as one value, or should we kind of break that up into monthly metrics or weekly metrics that, kind of start higher and move lower as the season goes on, but you're still maintaining that target, that median value over the seasons. We've been talking a lot about that with the Nature Conservancy and some of our projects because we're working in these small streams, and I think that that's where kind of the next phase of this project is going to go.
So let me jump to the next question, and it's from a very familiar voice, Barry Nelson from Golden State Salmon Association. Many of you know Barry well. And it's a long question, so I'm going to paraphrase it and boil it down to sort of the essence of it. And I'm going to, in fact, rearrange it so it's really a more direct question for you all. Why not just use unimpaired flows? And the difference between an unimpaired flow and the regulated flow is your water budget. Why not just use unimpaired flows? I mean, what's wrong with that? We get this question all the time, by the way. Ted, I'm going to probably expect you to weigh in first.
Sure, I'd be happy to. I think it's true that, depending on where you set that threshold, unimpaired flows could potentially provide the functions that we're focusing on in this approach. But I think the difference is the unimpaired flow approach doesn't actually consider whether or not those functions are being met. And I think this whole approach is really trying to focus on the functional aspects of flow and not just putting, water in the river for water's sake. Again, this is really a new idea that is just being put into practice. We have a few places like the Trinity and Putah Creek where we see sort of elements of the approach, but I think there's sort of a hope that by focusing on satisfying these key functions rather than just setting an unimpaired flow target, we can actually make more water also available for other uses. And so I think that this, not only by focusing on functions can we have better ecological outcomes, but we can potentially have a lower impact on water users and alternative uses of water.
I'd like to input on that a little bit. I think one of the problems is that when you have a river that's severed in half by a dam, that river now has to fulfill all the functions that the headwater, main stem, and lower river did in a much shorter space. So looking at the Trinity, for example, if we just use unimpaired flow, the record low flow at Lewiston in the 1930s was like 26 CFS. The minimum flow in summer now is 450 cubic feet per second of cold water. The difference is that without the dam there, the fish could get all the way up into the very headwaters into Coffee Creek, Stewart's Fork, and spend the summer in the cold mountain streams. Whereas now, right below the dam, that must function as the headwaters now. So if we were to just say, look, let's just provide unimpaired flows to the Trinity at the old temperature, you'd be providing mid-main stem, low drought flows, warm temperatures to an area that must now function as the headwaters, given that there's lack of fish passage. So this is among some of the reasons why it is tempting, and we always look at the unimpaired hydrograph, but it sometimes cannot provide the full functions of a river, especially for rivers that have dams on them now.
Cool.
Yeah, and maybe just to follow up on that too, like I think a lot of the times in the places where we're trying to come up with these flow criteria, where it's rivers that we're really interested in, it's places where they aren't, the flow that is coming into them currently is not meeting the needs of that river because of other changes we've made to the landscape or changes to riparian cover or damming. So thinking about the functions that we're actually hoping these flows will achieve is going to help us really target the pieces that maybe aren't there for the species that maybe aren't doing so well. And as Ted was saying, it also kind of like helps us focus on those areas that we think are really important, rather than saying everything's important and then just letting a later water manager make that decision without maybe taking into account the full scope of knowledge we have about what species are really going to benefit from.
I got really two questions I want to get to, which are important here, and I hope I'm not cutting you off, Bronwen, on this. But it would not be a PPIC dog and pony show if we didn't talk about the Sustainable Groundwater Management Act. This has driven so much work, and we're actually getting multiple questions about the relationship between Functional Flows and Sustainable Groundwater Management Act. And Julie, I'm going to actually direct this to you because the Nature Conservancy is involved so much in this. So Jose Rodriguez from UC Merced has pointed out that if you want to implement functional flows, aren't you actually likely to take away the very thing that we need right now for recharge? And that would be the flood pulse, for example, in these rivers. If you're going to focus on environmental flows, does this not represent one of those difficult trade-offs that Ted alluded to that they're going to be tough to manage? Julie, you want to tackle that?
Sure. I mean, something under Sigma is that you can't have any detrimental effects to, surface water and those habitats that are maintained by surface and groundwater. And so I don't think you could ever just take all the flood flows and meet the spirit of the act. So the idea with the functional flows is that you provide some of these flood pulses, but not all of them. So I think that there's still some water that can be, taken for recharge. But it's being mindful that you're not just cutting off those high flows and just flatlining the river. I mean, that's what we've done in most of our regulated rivers in California, right? We've taken that variability and we've just kind of smushed it. So we have more water in the summer and less water in the winter in places where we've been able to do that. And I think the idea is that as we work on these recharge projects, that we don't make that worse. So we're maintaining, some of the flood pulses that you need for rivers to function, but then having some guidance about which of that water you can use for those other purposes.
Yeah.
And I just add briefly to that.
Yeah, please.
I just wanted to say, I mean, depending on the strategy that's being used to recharge groundwater, getting water onto the floodplains for recharge benefits can also, if it's done right, can also provide a host of ecosystem benefits. So it's not necessarily a direct sort of trade-off between getting water into the ground and getting water onto floodplains and providing these functions. I mean, in addition to the point that we don't need to preserve every single flood pulse that comes down the river.
So I'm going to follow up with another. Well, there's a couple of thorny questions here, and they're good. They're good questions. I mean, Patrick McCarthy, from the conservation director from the Colorado River Program of the Nature Conservancy, points out the obvious, that about 90% or more of ongoing e-flow projects are related to endangered species. How do we get past that and go to this thing? Mike alluded to this, the importance of managing for all of these conditions. How do you do that within the context of the Endangered Species Act? And I leave this open to all of you. I mean, it currently drives the way we manage it, and poor Ted's been on multiple reports and all of this, but I want to hear from everybody. How do you get around the fact the Endangered Species Act wants you to focus narrowly on a few individual species?
I think one thing to keep in mind is that when you're managing flow under the Endangered Species Act, you're just avoiding jeopardy. You're not restoring anything. It's not meant to do that. So this is one key difference that I see from this approach, is that we're actually trying to move past that. So you would need certain flows under ESA to avoid jeopardy so you don't lose species, but then move towards a more functioning ecosystem. So I think, in most cases, it'll be additional water and additional habitat, because we've really kind of worked within the space of just giving the least amount possible so that things don't go extinct.
So I'd like to, we use the Endangered Species Act like a drowning victim uses a piece of flotsam floating on the water. I'd rather be sitting in a boat, but I got to stay alive. So we grab onto the Endangered Species Act. We've brought litigation within Species Act. We participate in reconsultation, but I'm telling you this, what we're seeing right now is we're fighting a lawsuit where the US government's getting ready to say that it doesn't have an obligation to even release Endangered Species Act, that's all under state law, and they're going to ditch Section 7 consultation. I think they're trying it out on the Klamath first. This is pretty new. I would definitely be keeping a real eye on this lawsuit. It's called Klamath Irrigation District versus Oregon, and the US is saying that they're going to abide by the state ruling and not release any water for endangered species in the near future down the Klamath.
Okay, I have to wrap this up, everybody. So first of all, thank you to the panelists, and thank you to Ted for your wonderful presentations. I want to remind you that the SD Bechtel Jr. Foundation and a suite of wonderful funders funded the PPIC CalTrout Ecosystem Fellowship that is for Ted. Next year's fellow is Letitia Grenier from the San Francisco Estuary Institute. I want to remind those of you who pre-registered for this event, later today, you will be getting a survey from us. Please, we need these surveys to help improve these presentations. It's extremely important. And most of all, to each and every one of you, be safe, be healthy, and have a good afternoon. Thank you very much.